Madan sir here, and today I'm taking another very important topic, and it's again from the carboxylic acid. And what this time I'm about to explain you. This is about the physical properties of the carboxylic acid. So it's going to be some 5-6 points about, and they're going to be important, but also going to be very easy. So let's start that and see what this is about. So the first thing in that sequence I'm taking, is to make you understand what is the color of the carboxylic acid, right? So I'm talking about the color. So what I would write here is that they are colorless. They are colorless, right? Second thing I would write about, that they are actually their physical state. I should, talk about physical state. They have physical state, up to 9 carbon, they are liquid. Up to 9 carbon, they are liquid. But with more number of carbon, they exist as wax-like solid, right? So the lower, carboxylic acids up to 9 carbon, they are liquid. However, if you increase the number of carbon, you try to find out what the physical state is, they appears to be a wax-like solid, not very hard solid, but a wax-like solid, right? Another thing that's going to be the third one is that they have unpleasant odor. So the third thing is about odor, ODOUR. So we are talking about the odor of the carboxylic acid, which is unpleasant. So what that means, you won't be liking, like aldehyde and ketones, if you remember, they were having good fragrance, so they are used in artificial sweetening agent, they are also used in making perfumes and etc. But carboxylic acids are not something you can use as a fragrance here, so they are unpleasant. What next we have is that, they are non-volatile, right? And it also relates that their boiling point, I'm talking about the boiling point now, they have highest boiling point as compared to other, highest boiling point, it's okay. So they have highest boiling point as compared to other organic compounds. What other organic compounds I am talking? Compounds are like alcohol. I'm talking about even, that aldehyde, and I'm talking about ketone as well. So ketones as well. And but of comparable mass. Let me write one very important thing, of comparable mass. So what that mean here is that carboxylic acid's boiling point is highest, when it compared with alcohol, phenol, ketone and all of similar number of carbon. So they are having highest boiling point. Why the boiling point is highest? That's very important. So I'm giving you the reason because of more extensive hydrogen bonding. More extensive hydrogen bond between the molecules. Right? So let me show you how this boiling point is high because of hydrogen bond. But before that, let me take you through the 6 very important point here. On heating, when you heat them, they form vapor. Vapors, but even the vapors exist as dimer. exist as dimer. Exist as dimer. Now what this dimer is, let me tell you. When you start to boil a carboxylic acid, what happens, they form vapor. But even if they form vapor, they are not absolutely isolated in terms of a molecule. Why? Because some of the molecules still remain together in the form of a dimer or trimer or a polymer. So how a dimer looks like, that's very important here. So I'm taking any carboxylic acid I can take. Let's take ethanoic acid here. So this is your ethanoic acid here, right? And this is another ethanoic acid I am talking. This is another ethanoic acid I am talking. So what happened here? There is a hydrogen bond. So there is a hydrogen bond. So due to the hydrogen bond, what kind of hydrogen bond? Intermolecular hydrogen bond. Intermolecular hydrogen bond, they still remain in the form of a dimer, right? So this is very important about the boiling point. Let's talk about some of the other physical properties of the carboxylic acid. Now the question is, what about their solubility? So this might be the last thing. So the seventh topic I am taking you through is the solubility. Up to 4 carbon, they are water soluble. They are water soluble. But higher ones are water insoluble. Now the question, let me repeat back here. Up to 4 carbon, most of the carboxylic acids are water soluble. Why? Because they can form hydrogen bond with water, right? But other carboxylic acid with more than 4 carbon, they cannot be soluble in water. So therefore they are soluble in organic solvent. Now the question is, why the carboxylic acid with up to 4 carbon are water soluble? Let me show you. Because they can form hydrogen bond. So I am taking again ethanoic acid here. Ethanoic acid, this is your ethanoic acid here, and let's place a water molecule here. So let's place a water molecule here. You do know that it has a 2 lone pair. So what happened? This lone pair is used in making a hydrogen bond. Let's take you through another hydrogen bond also. It can also form another hydrogen bond here. So because the carboxylic acids can easily form hydrogen bond, so they are water soluble, but as you increase the number of carbon, the solubility of the carboxylic acid also decreases. Now one more thing I want to add is about the benzoic acid, right? So benzoic acid solubility I am talking. One very simple thing about this compound is that since it has more than 4 carbon, so it's also water insoluble, right? So benzoic acid is water insoluble, and all other carboxylic acid with more than 4 carbon, they are also water insoluble. What that means? They are soluble in organic solvent, right? So these are some of the topic actually I wanted to mention, and with that I have to finish it right here. I would say thanks for watching, take care and good night.